Hello and welcome to our 8th lesson on the solar system. Today we'll be talking about Saturn and its moons. But before we start, I wanted to say, first of all, I really missed not being able to come over and teach the class to you. And I thought this would be a way where at least some people would be able to keep up with the class. But I want to emphasize that once I'm able to come back there, I will do that, and you'll get to see these remaining lessons about the solar system presented by me live and in person. But I thought in the meantime, people who might not have anything to occupy their time might like to see the lessons. So here we go. Saturn, the second largest planet in the solar system, has a radius of 36,000 miles, slightly over 9 times the radius of the Earth. It orbits the Sun at a distance of 9.5 astronomical units. Now, you might have forgotten, but when we talked about Jupiter, we said Jupiter is about 5 astronomical units from the Sun. And the astronomical unit is just the distance from the Earth to the Sun on average. But that 9.5 AU is about 800 million miles. So that's the average radius of Saturn's orbit. It's almost twice as far from the Sun as Jupiter is. Saturn is easily seen in the night sky, and so it's been known to be part of the solar system for all of recorded history. Galileo was the first person to observe Saturn with a telescope in 1611. He saw the rings of Saturn, but he had no idea what they were, since his telescope wasn't able to resolve them and show the ring shape. He just saw something sticking out from Saturn on either side. So in his notebook, he wrote that there were two moons exactly opposite each other on the side of Saturn. And he went back and looked again a few months later, and he was very surprised that he couldn't see those moons anymore. This happens because as Saturn moves around its orbit and the Earth moves around its orbit, sometimes the orientation of Saturn with the Earth is so that we see the rings directly edge on. Now, with a modern telescope, when this happens, the rings just look like a line passing through Saturn's surface. But Galileo's telescope was not able to see that line at all, so he thought the moons had just completely vanished, and he was really surprised. A day on Saturn lasts about 10.6 hours, but a year lasts 29 Earth years. Saturn's axis of rotation is inclined about 26.7 degrees to its orbit. That's a little more than the Earth, which is at an angle of about 23.5 degrees. So Saturn does have seasons like the Earth does. It has 4 seasons just like we do. But because the year is 29 Earth years, these seasons are almost 7.5 years each. Like Jupiter, Saturn is mostly made up of hydrogen and helium. It may have an inner core and a rocky mantle, but they would be very small because Saturn's density is very low. In fact, it's less than the density of water. Also, like Jupiter, Saturn has extensive storms in its atmosphere. Winds on Saturn exceed 1,000 miles an hour. One storm, which was discovered by the Voyager 1 mission in 1980, is a hexagon-shaped storm at the North Pole of Saturn. Of course, Saturn's most conspicuous feature is the ring system. The rings are composed mostly of water ice, which is why they are so reflective. There are at least 7 complete rings and then several partial ones that don't go all the way around Saturn. The best current theory is that the rings are the result of one of Saturn's moons getting too close to Saturn and being torn apart by the gravity of Saturn. A number of Saturn's moons appear to be composed mainly of water ice, so that would explain why we have these icy rings. Interestingly, the theory also says that this event happened relatively recently in astronomical terms. The theory says that the rings were created about 100 million years ago. So that's back when there were still dinosaurs that the rings actually got created. Even more interestingly, though, the rings appear to be disappearing, slowly but surely going away. The Cassini space probe orbited Saturn between 2004 and 2017, and it made its final few orbits actually inside the rings, between the rings and the upper atmosphere of Saturn. On those orbits, Cassini discovered that material from the rings is falling down into Saturn's atmosphere. This phenomenon is now called ring rain. Cassini was able to measure the rate of ring rain, and based on that and on the approximate amount of material in the rings, astronomers estimate that the rings will be completely gone in about 300 billion years. So we're actually pretty lucky that we're around at the time those rings are there. Saturn has a magnetic field which causes auroras, but the field is much weaker than Jupiter's, so the auroras on Saturn are not nearly as prominent as those we saw on Jupiter. Like Jupiter, Saturn has an atmosphere composed primarily of hydrogen and helium, with small amounts of methane, water vapor, ammonia, and other gaseous compounds. Also like Jupiter, the top of Saturn's atmosphere has a banded structure. Saturn's bands are not as colorful as those of Jupiter. As we mentioned before, the winds in Saturn's upper atmosphere blow at about 1,000 miles an hour. Those winds push huge storms across the surface of Saturn. Here's a view of Saturn showing the North Pole and the rings, and notice that the shadow of Saturn actually covers part of the ring. So the sun is shining in from the right, and the resulting shadow blocks off part of the rings. This is a storm at the North Pole of Saturn. Now, I have to tell you that doesn't really look like this. The true image is black and white. It was colored like this so that you could look at the shape of the storm more clearly, but it's really not red and blue. But you can see there, notice if you look in the center red part, you see that hexagon shape, which is really quite unusual, and nobody really knows why it has such a geometric shape as that. Here's a picture where we see what I talked about earlier. Here the rings are in fact edge on. That thin line going right through the middle is the actual rings. Now what you see below that, because the sun is coming in at an angle from the top, shining through the rings, and so what you see below that line is the shadow of the rings on the surface of Saturn. And also, if you look up toward the top of Saturn, you'll see that storm that's blowing all the way across almost half the planet. Now we have here a series of images of Saturn made by the Hubble Space Telescope. It started in 2000, so the first one was in 2000, and then it did one a year. And if you look carefully at this picture, you'll be able to see a couple things. One is that over time, the orientation, what it looks like to us, like the rings are sort of moving around with respect to, like to be wobbling up and down, but that's not really what's happening. what's actually happening is our perspective is changing because of the relative orientations of the Hubble Space Telescope and Saturn. So that makes the angle of the rings look different. The other thing you can see, if you look at the starting from the bottom left, you'll notice that light-colored band, and then as you go up, it gets darker and darker, and finally totally disappears. I said that these were taking 1 a year, so that's 5 years on Saturn. So that's a good part of one season. So we're seeing some kind of seasonal effect there, where the change in the season causes this one band to change color. So I guess basically we've pretty much described most of what I've got to say here already, so I won't read it again except for the last point, which we're going to see another picture of in a second. That the storms on Saturn produce flashes of lightning in Saturn's upper atmosphere. And some of those flashes were actually captured in images taken by the Cassini mission. And that's what this next slide is showing us. Here's down here at the bottom is a lightning storm on the in the upper atmosphere of Saturn, and this is one of the instruments on the Cassini spacecraft, which measures the radio signals produced by the lightning flashes. And you see all these jaggedy lines which represent lightning flashes occurring in that storm. Now here we get a very interesting picture that gives us a lot of information about Saturn's rings and a number of its moons. Saturn actually has a total of 82 moons, which is actually even more, well, at least right now. We know Saturn has 82, and I think our last number on Jupiter was 79. So right now we think Saturn has the most moons of any planet in the solar system. Now those moons range in size from Titan, which we're going to be talking a lot about in just a minute, all the way, and Titan, well, it's bigger than Mercury, I'll just say that now. And we get all the way down to little tiny moons that are only about half a mile wide. The other thing here is this picture shows us the position of all the rings. Now you might wonder at the names of the rings. Here's the A ring, and then the B ring, and the C ring, and the D ring, but then here's the F ring here, and here's a G ring here. And way out here is the E ring. So you probably are wondering, how come they're not in alphabetical order? Well, here's the reason. When the rings were first identified, which was about 1670, when they finally made a telescope that was good enough to resolve the ring structure, it was thought that there was just simply one ring. But then as telescopes got better and better, they were able to make out these gaps between rings. And when they did, the first ring they identified is this one we call the A ring, and the one next to it the B ring. But then then they identified the C and D rings, and then not till much later on this E ring, and then later the F ring, and so on. So the letters actually represent how long ago the rings were discovered. So the A ring is the oldest one. You also see some of the smaller moons of Saturn in this picture. Notice that there's some of them actually in the rings themselves. There's a moon called Pan, and a pair of moons called Prometheus and Pandora. And then there are other moons that are in this gap between the G ring and the E ring. And then this moon Enceladus is actually right in the E ring. In fact, we're going to see Enceladus actually creates the E ring. It shoots out water which freezes and produces this very thin icy E ring. We have then a couple of more moons, and then coming out here to this moon Ray, and then Titan is finally further out. It's actually outside the picture. There are 29 moons that are about 5 to 10 miles wide each that are very far out from Saturn, and they also orbit Saturn in a direction opposite to the planet's rotations, unlike most of the moons, which orbit in the same direction as Saturn's rotation. So the most likely explanation for this is that these moons are actually captured asteroids that came too close to Saturn and it got captured by its gravity. Saturn's largest moon, Titan, has a radius of 1,600 miles, which makes it slightly larger than Mercury and 50% larger than our own moon. It takes Titan 16 days to orbit Saturn, and it's tidally locked so that it completes one revolution around its axis in the same time. So what that says is if you were able to sit on the surface of Saturn, which you can't because there's no surface, it's all gas, you would always see the same side of Titan, just as we always see the same side of our moon. Titan's axis of revolution is tilted less than 1 degree with respect to its orbital plane, which means that it essentially shares the same seasons that Saturn has. Unlike any other known moon in the solar system, Titan has a dense atmosphere consisting mostly of nitrogen with small amounts of methane, ethane, and other hydrocarbons. The atmospheric pressure on Titan is about 50% greater than atmospheric pressure at the surface of the Earth. In fact, because of two things, because of this dense atmosphere and because Titan, being a lot smaller than the Earth, has a lot less gravity, if we were ever able to send astronauts to Titan, if they attached wings to their arms, they could fly. They could just flap their arms and they'd take off and fly just like birds. So it kind of makes you wish you could be an astronaut and go to Titan. The methane in Titan's atmosphere creates a smog-like haze, similar to what we see in the summer. If you look towards downtown Atlanta in the middle of say, July, almost always see this sort of dirty-looking haze hanging over the city. That's actually caused by the same thing. It's caused by the gases that cars give out in their exhaust that get trapped in the air above the city, and they turn into this smog. The temperatures on Titan's surface vary a little bit depending on what season it is, but they're always very cold. They average about 290 degrees Fahrenheit below zero. At these temperatures, water, which is plentiful on Titan, is frozen so solidly that it acts like rock. Methane and ethane are usually liquid on Titan, but if it gets very cold, they can freeze also. When the Cassini mission began orbiting Saturn, it was able to make detailed observations of the surface of Titan and discovered it resembled the Earth in a lot of ways. On Titan, methane plays the same role that water does here on Earth, and water ice plays the role of rock. The resulting landscape is amazingly Earth-like. The Cassini mission had, in addition to its orbiting probe, a lander built by the European Space Agency, which descended to the surface of Titan and sent back images of the surface. Cassini also used its radar imaging to penetrate the haze in the upper atmosphere and showed methane lakes and seas on the surface of Titan. The radar also revealed the seasonal weather effects. When Cassini arrived at Titan, it was winter in the northern hemisphere. Radar images of the surface of lakes near the North Pole showed them to be completely flat and smooth. Later, the northern hemisphere moved into warmer temperatures, and the radar showed waves on the lake surfaces, indicating that winds had become active. Now we're going to see a video of Cassini's lander descending to Titan's surface. The first part of the video is animation, and then we get actual video taken by the lander camera, and then there's a little more animation at the end. Now, because the video had this dramatic music, I wasn't able to talk while the music's playing because you wouldn't hear me. So you're going to see everything happen, and there are captions to explain it, but then when the music stops, you'll hear me once again explaining what's going on. Okay, that's the end of the video. I think I couldn't talk because of the music being so loud you wouldn't hear me, but I think the captions pretty much covered what we saw, but I'm just going to give you a little reiteration of what it was just to make sure it's all clear. There's actually three parts there. First part is animation, where it shows you what it would look like, what it did look like when the lander detached from the orbiter and descended down to Titan. Then at some point it switched to actual video recording that showed you what it looked like as it got closer and closer to the surface. And at first all you saw was just that orange haze, and then you started seeing those mountains coming through the haze, and then there were the channels for the rivers. Remember, the mountains are actually made of ice, just plain old ice like you put in your iced tea, except much colder. And the rivers actually are liquid methane. Then we finally start seeing the ground, and it's not really dirt there. What it is, we talked about that haze. As you know, the kind of haze we see here in the summer, actually, it's not just gas. There's solid stuff up there, little soot particles in the haze, and they can fall down to the surface. So that's what happens on Titan, is that haze contains solid particles, and they fall down and they make the actual surface that the lander ended up on. But you also saw those rounded rocks, which again are just big pieces of ice frozen very solidly. And then we saw the shadow of the parachute that helped it get down to the surface passing over. And then we switched back to animation, and they showed you the picture of the lander attached to the parachute and how it landed, and then the parachute came down a little bit away from it. And the final point I wanted to repeat, just because it's so amazing, is that this landing of this lander on Titan is the furthest landing of any human-built object from the Earth. We've sent stuff, we've landed things on the moon, of course, we've landed things on Venus, and we've landed things on Mars. But this is much, much further away than any of those. So it's the most distant landing of any human-built object in the solar system. Now, this picture is showing us the changes in Titan that take place over a season. So if you see the little square, that's the area that's shown in these 4 pictures on the left. The first one was taken in 2007, and then the next one is in 2013. Well, this is a little island made of frozen water ice in a methane lake, and this is what it looked like in 2007. Well, in 2007, this part of Titan was entering its winter season, and so remember, seasons are 7.5 years long. So by 6 years later, in 2013, we've got all this new area that wasn't there before. That's stuff that's frozen because the temperatures have gotten colder in the winter. Then in 2014, we see it starts going away, which means the temperatures are warming up again. And by 2015, it's completely gone. So basically what these 4 pictures show us is the passing of the winter season on Titan. We start out as winter begins, and down here winter's over and spring is coming back. Now, this is Saturn's moon Enceladus. It's very small, only 160 miles in radius, but it's in a lot of ways it's extremely interesting, and you can see some of it in the picture. You'll notice that we see some craters, but the whole surface isn't cratered. Large parts of it are smooth, and you also see these things that look like maybe cracks. What we have here in Enceladus is primarily ice, water ice. But like Jupiter's moon Europa, Enceladus is subject to tidal friction. As it orbits Saturn, it has an elliptical orbit, sometimes closer, sometimes further away. It also has the gravity of the moon Dione, which is close to Enceladus, pulling on it. So between the two, Enceladus, the surface flexes up and down, and that creates tidal heating, and that melts the ice beneath the surface. And so Enceladus actually has a huge liquid ocean under that icy crust. We see that some of the water must be leaking through those cracks, and that's what makes the surface so smooth, that when a meteor hits Enceladus and makes a crater, After a while, water will leak out from one of the cracks and cover that crater over. It'll freeze solid and it's gone. Now, the other thing that the Cassini mission discovered about Enceladus was that there are actually geysers of liquid water vapor erupting from the south polar region. We're going to see a picture in just a minute. It looks like this happens continuously, that water is constantly escaping from the south polar region of Enceladus and going out into space. And as we mentioned before, that helps to form that E-ring. The Cassini probe actually flew through those geysers and managed to analyze the water vapor. We already knew from Hubble images that the water vapor also contains some methane and carbon dioxide and some nitrogen. But Cassini found also molecular hydrogen in amongst that water vapor. Now that's very interesting because we have these deep volcanic vents beneath the Earth's ocean, and they also produce molecular hydrogen. So it's very interesting that we see the same thing happening on Enceladus. It makes Enceladus a place where some biologists think there's a possibility you might have life. Some kind of simple single-cell life might exist there. Now here's a picture of Enceladus. This one was taken by Cassini, and you can see right there that water vapor escaping from beneath the ice. Now there's another interesting moon of Saturn, which is named Mimas, which is called the Death Star moon. You might wonder, why is it called that? Well, there's a picture of Enceladus, and there's a Death Star from Star Wars. And you see, not only does it have the right shape, but it's even in the right proportions. So it's kind of amazing. One of these days, I'm going to look up and find out if they actually came up with the shape of the Death Star in Star Wars based on Enceladus. I really don't know, but you would almost think they must have had to. So Saturn is visited by a total of 4 space probes. Pioneer 11 flew by it in 1979. Later in that same year, Voyager 1 flew by, and then in 1981, Voyager 2. The Cassini mission was launched from the Earth in 1997, and it arrived at Saturn in 2004 and went into orbit. And it stayed there until September of 2017. And its final 22 orbits around Saturn were very close to the top of Saturn's atmosphere. We mentioned it actually went inside all the rings. And we learned a lot about the upper atmosphere of Saturn by those last few missions. At the completion of those orbits, then the probe was allowed to fall down into the atmosphere and burn up. And the reason they did this is they did not want it to crash into one of Saturn's moons, particularly not the moons like Titan or Enceladus, because if there were bacteria brought from Earth on the probe, then it could have contaminated those planets. And then we would never know for sure if they had life of their own or if the life had been brought from the Earth.